multi-strip two-dimensionally, it looks like this. All right, so what does this look like? It looks like a sideways 8, right? So what do we call this? We call this each and every. Go ahead.
Oh, sorry. It just looks like an infinity where it has no end nor beginning.
Okay, very good. All right, each and every single point on the multi-strip not only will represent a time dimension, space dimension, x, y, z. It's also going to represent the time dimension. All right, so this could be a point in the present. This may be a point in the future, point of time in the future, and here's a moment in the past that you're looking at. So notice that each and every single point not only represents the x, y, z dimensions, but every single point is also going to represent the time dimension. So each and every single point represents a moment in time. So notice that this moment in time, the present exists, the future is going to exist, the past is going to exist. Now, for us to be able to do time travel, space-time continuum needs to be curved. Why does it need to be curved? If it is curved, time travel is going to become possible according to. All right, so the Mobius strip. All right, guys, pick and choose the best answer first. Your test will have questions like this, so some of the questions will come from the quizzes, from class quizzes. All right, pick and choose the best answer. Which one do you think is the best answer? Let's have a discussion. So Mobius strip in this case, in this class, is going to represent what? What is the best answer? Based on the discussion that we just had.
Possible shape of space-time continuum.
Right. Give yourself 5 points for that one. The best answer, obviously, we're talking about the possible shape of the universe, right? So those of you guys who pick B, give yourself 2 points for that one. Jesus, give yourself 5 points for your. It's the possible shape of the universe that we will discuss. Now, this guy, his name is Kip Thorne. He's going to make time travel possible for us. He's a theoretical physicist, recently. And here's a picture of him from his hippie days from 1970.
Sagan, the noted astronomer, was writing a science fiction script called Contact, meeting extraterrestrial life forms. But he had a problem. The distance between stars is so great that it would take centuries to visit other planetary systems. And because of the time dilation problem, he decided to ask a physicist, is it possible to go these enormous distances in a twinkling of an eye?
Sagan called Professor Kip Thorne, a noted expert on Einstein's theory. Thorne struggled with the problem for some time. Then, in the back of a Ford Bronco, as he was driven along Interstate 5, he made one of the most inspiring connections of modern physics by linking Carl Sagan's cosmic conundrum with the exciting new concept of wormholes.
A wormhole is a hole in space that may give us a shortcut between 2 points. For example, if I had a super microscope and I could peer right into the fabric of space and time, I would find that it's not smooth at all. It's foamy, it's frothing, with tiny little holes and bubbles. If science can somehow tease apart one of these holes in space, we can actually connect 2 distant regions of space and time. Now, where have you seen that before? In Alice in Wonderland's Through the Looking Glass. The wormhole was Alice's looking glass that connected the countryside of Oxford with Wonderland, such that when Alice stuck her hand through the looking glass, her hand went through the wormhole and came out on the other side of forever.
Thorne was triumphant. Wormholes were an exhilarating means of connecting 2 points in space. It was only later that the full implications hit him. If wormholes could cheat space, they could also cheat time.
All right, so who's the name of the guy who came up with the idea of time travel through wormholes?
Kip Thorne.
Very good. Just remember that name because that name is going to keep coming out. So Kip Thorne is the guy who came up with the idea of time travel through wormholes. Okay, so what are these wormholes? Notice that the wormholes are shortcuts for the space-time continuum. If you have a wormhole which is connected to the future, it's going to take you to the future. If you have a wormhole connected to the past, it's going to take you to the past. All right, so here's your wormhole connected to the future. So you can go to the future. Here's a wormhole connected to the past. It's going to take you to the past. All right, the journey itself takes absolutely no time at all. That's you're in the present. You can leave 100 years into the future, spend 18 hours there, and then come back in the next fraction of a second. Or you can leave 100 years into the past, and then spend weeks there and come back in the next fraction of a second. That's what I do. You can come back by the time you leave, actually. Or you can come back before you leave. It makes no difference. All right, so this sort of stuff becomes possible only if there are shortcuts inside the space-time continuum. So there are shortcuts that we can take to do time travel. All right, so here's your shortcut to the future. Here's your shortcut to the past. So Kip Thorne is the guy who
Going forward in time at near the speed of light is relatively easy. Traveling backward in time seems all but impossible now, but it isn't ruled out by Einstein's theory.
All right, so let's have a quick discussion. Can we actually take shortcuts through the space-time continuum? All right, so for us to be able to do something like that, the first thing that needs to happen, literally, is we need to create wormholes. Okay, so what are these wormholes? Wormholes are 2 black holes connected together. All right, so if you have a black hole from the future connected to a black hole from the present, then it's going to give you a wormhole. Do we have black holes today? Of course we do. Do we have black holes? Did we have black holes yesterday? Once again, the answer to that question is yes, right? Do you think we are going to have black holes tomorrow? More than likely. So if Kip Thorne is correct, if the future, the past, and the present all exist at the same time, and then if these black holes become connected, then they will turn into these wormholes. All right, we got a bunch of problems. one of the problems is when there's a connection like that, those connections only last for a fraction of a second. The second problem is you're dealing with black holes. At their centers, the black holes are smaller than the smallest atoms in your body. All right, so if you were to jump into one, depending upon the connection points of these wormholes, if the opening is not large enough for you, you can get crushed. And the third problem is the radiation. Tremendous amount of radiation. So much radiation, in fact, that you will get vaporized. So there's no way you can actually do time travel through these wormholes unless you can stabilize these wormholes. So the question is, how do you stabilize these wormholes? That will make time travel possible.
If Joe Tanner in his super shuttle wanted to go back in time, he would have to locate a black hole. And not just any black hole, a special black hole connected to another light years away. The resulting tunnel in time and space is called a worm.
Alright, so what are these wormholes? These wormholes are shortcuts for the space-time continuum, and they will only come into existence if black holes from different moments in time become connected somehow. They're highly unstable. I mean, obviously they exist in theory, and if they do exist in reality, they would be highly unstable. And you would have a bunch of problems. The problem is that both the open at the center may not be large enough for you to go through, or the radiation may vaporize. So they need to be stabilized. Alright, so I'm going to ask you a bunch of questions. Who is the author of Contact? Alright, so let's go back and have a discussion one more time. Who's the guy who came up with the theory of time travel, guys? Through wormholes. His name is Kip Thorne, right? Okay. Kip Thorne. Where was he when the idea struck him?
I was on the freeway.
He was on a freeway. Freeway, what's the number? It's 5, right? And near LA. What else? What else do you know about him? What kind of vehicle was he in?
Like a Bronco.
Yeah, you guys got it. All right, so this sort of stuff that you guys pay attention to, it's kind of interesting. All right, so his name is Kip Thorne. He was was he a passenger or was he driving?
I think passenger.
He was a passenger. All right, where in the vehicle? Where was he seated inside the vehicle?
In the backseat of the car.
Okay, notice the details. Some of you guys are still paying attention to these details. So he was inside a Ford Bronco. He was in backseat of a Ford Bronco, and he's actually pondering about this question. Right? Does anyone remember the color of Ford Bronco by any chance?
White.
Jen, you end up picking white. Why did you pick white?
Because I thought it said white.
You thought it said white. Okay, that's actually cute. All right, so here's what's happening, guys. The details that you guys are paying attention to are not really relevant, but you guys are still paying attention to it, right? All right, his name is somewhat relevant because it's going to come up, Kip Thorne, so I want you to remember that. In fact, Kip Thorne is the guy who's going to make this aspect of this course possible. The time travel aspect. He's in a Ford Bronco, Highway 5, not relevant. He's in the backseat, that's not relevant. The color of Ford Bronco is not relevant. It's not white. They didn't mention that color. Jen, you're making a connection to O.J. Simpson case. Ford Bronco is kind of, your mind is just filling in the gaps. It's kind of weird. The only question that I have is, why is he thinking about wormholes? Why is he thinking about time travel? He's thinking about wormholes. He's thinking about time travel because this guy who's writing a book on contact wants to know if it's possible, right? So what is the name of the guy who's writing a book about contact? By the way, Contact is a movie that you guys will get to watch in the next 2 days, and you will be tested on it too. So we will go over the list of the movies that you have to watch, the documentaries and the movies. All right, so what's the name of the guy? What is the name of the guy? Let's get back. All right, so that's one detail that you guys missed.
Sagan, the noted astronomer, was
What's his name?
writing a science
Carl Sagan.
fiction.
Carl Sagan. Does anybody know who Carl Sagan is? Does anybody know who Carl Sagan is? Carl Sagan. Control H. How many of you guys seen the Cosmos recently? The documentary Cosmos? Alright, so Carl Sagan, you will get to watch the documentaries. This guy actually made a documentary which is about 10 or 11 hours long, and one of the first people who tried to popularize science. One of the biggest names in astronomy, as it so happens, and you will get to know him quite well. So, obviously, the first movie that you will get to watch is going to be his Cosmos.
Going forward.
Alright, so who's the author of Contact?
Sagan.
Carl Sagan. Alright, give yourself. Alright, so who's responsible for the theory of time travel through wormholes?
Kip Thorne.
Kip Thorne. Alright, those of you guys pick Kip Thorne, give yourself as well. So, for time travel to be possible, so 2 things that we established so far. Number 1, the time needs to be a continuum. Number 2, it needs to be curved, right? If it's flat, you're not going to be able to do shortcuts. If it's curved, you may be able to shortcut, and you may be able to take shortcuts.
Suppose a wormhole does twist time as well as space. Suppose NASA engineers were able to keep two wormholes open and connected using a repulsive gravity source. Suppose the super shuttle could navigate through the connecting tunnel. Suppose they found Elvis out there. Suppose. Cosmologists do a lot of supposing.
All right. Now, for us to be able to do time travel, obviously we will need wormholes. And for us to be able to go through wormholes, we have to stabilize. So how do you stabilize a wormhole? So it's large enough, opening is large enough, and there's not much radiation, and then the gravity is not going to crush us. So we're not going to get crushed. We can stabilize these wormholes by using something that generates repulsive gravity. So Kip Thorne is the guy who was actually considering this problem, and he knew that the solution of this problem would be using something that would generate repulsive gravity. He's coming up with these theories in the 1980s, and back then there's nothing. There was nothing in physics that would actually generate repulsive gravity. There was not a single theory, and there was no single concept which was responsible for generating repulsive gravity. So he ended up coming up with something on his own. He said, let's call this thing that generates repulsive gravity exotic matter. So he came up with the idea of exotic matter. So what's exotic matter? Exotic matter is matter. It's some kind of a science fictional matter that he himself came up with that should generate repulsive gravity. Unless you have something that can generate repulsive gravity, you cannot stabilize these black holes or wormholes enough so that you can actually do time travel. So that would be impossible. And then something happened in 1990. Physicists discovered that the universe was expanding, so no surprise there. What was surprising was the fact that as the universe was expanding, it was actually accelerating, which means that it was speeding up. The fact that it was speeding up meant that something was pushing the universe in the opposite direction. Something was generating repulsive gravity. We still don't know exactly what that is that generates repulsive gravity, so we call it the dark energy. All right, so Kip Thorne's exotic matter from the 1980s became our dark energy in 1990. All right, so what is dark energy? Dark energy is what generates repulsive gravity. And so what is it responsible for? It's responsible for the expansion of the universe. While the universe is expanding, it's accelerating, which means that the universe is speeding up. All right, despite the fact that we don't know what it is, and hence the reason we call it dark. All right, if somebody says dark energy, which means that we know that it's something that generates a tremendous amount of energy, in this case, repulsive gravity, but we don't know what the source of it is. If somebody says dark matter, it's a matter that you cannot see, which means that it generates a tremendous amount of gravity, but we don't know what the source of that gravity. That's the reason why we call it the dark matter. So dark energy generates repulsive gravity, and dark matter generates attractive gravity.
Now, one of the theorems that was proven many years ago is that if you create a wormhole in a region of space where it never existed before, you must also twist time in such a way that time travel becomes possible. In other words, not only do you have created a hole in space, you must also have twisted time around so that it becomes possible to return to your starting point in space-time before you left. You automatically create a time machine when you create a... is what...
All right, so now we got problems. The problem is the time travel. Regarding time travel, problem with... No. Okay, so regarding our problem of time travel. 3 conditions need to be satisfied. The first condition is that time needs to be a continuum, which means that the past, the present, the future all need to exist at the same time. The second condition that needs to be satisfied is it needs to be curved, kind of like the movie strip. If it's flat, you cannot take shortcuts. If it's curved, that allows you to be able to take shortcuts through wormholes, obviously, if that's a possibility. And the third condition needs to be satisfied that it's going to come out of the following scenario. All right, so imagine that the time travel is possible, so I can go 100 years into the future and spend 18 hours there and come back with the next fraction of a second. All right, so the wormholes will allow that to happen. So forget about going to the future, all right, because we don't know what the future holds. But the past, we do know 100%. That's known as history, all right? You can go back 100 years into the past. You can go back 50,000 years into the past. It doesn't matter. So why don't we just go back to the past that we know and then try to make some changes? I'm talking about, why not just go back maybe about 50 years into the past or 60 years into the past? Find Hitler and kill him before he starts World War II. And now what happens to the present? What do you think? So go back to the past and find Hitler and kill him. What happens to the present? So,
Wouldn't it create a butterfly effect? It would change things in the present?
all right, so absolutely, right? So you go back in past and then you just find him and you kill him, and then next thing you know, the history completely changes.